feelings well up inside you when I say the word proof? Okay, we have, I don't want to do it. We have vomit. We have anger. Okay, Maddie and anger. I don't. Anybody see anger going with Maddie? I don't. Okay, all right. Okay, okay, all right. Maddie, I would like to see anger invoked at some point of this year. Are you ready? It says, prove the following statements using the piecewise or precise definition of a limit. The limit is x approaches 2 of 3x plus 7 is equal to 13. What is the function? What shape does that make? What x value am I approaching? Do you agree that the limit would be 13? Okay. Then what we do is this. Choose an appropriate delta. Do you recall that in all the examples we have done thus far, you've been finding delta? You should be excellent at finding delta at this point. Here's how we choose delta, and this is step 1 of the proof. There are 2 steps. Remember, part of the definition, the precise definition of the limit was the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus a is less than delta. So I'm going to write that out. The absolute value of f of x. What is the absolute value of f of x? I'm sorry, what is f of x? 3x plus 7. Minus, what is the limit? 13. Is less than epsilon. Whenever the absolute value of x minus what is a is less than delta. Here's how we choose an appropriate delta. We make the left side look like the right side. Watch the magic happen. 3x plus 7 minus 13. Combine like terms. What do you get? 3x minus 6, less than epsilon. This is starting to look closer to that. I'm going to factor out a 3. Does that look even more similar to the right-hand side? Anybody want to guess what I do now? I'm going to divide both sides by 3. And I get the absolute value of x minus 2 is less than epsilon over 3. Everybody see that? So would you all agree that the left side looks very similar to the right side? What is the only difference? The epsilon over 3 and the delta. Agreed? So therefore we choose delta to be epsilon divided by 3. If you remember yesterday, I did an example with you where we chose epsilon or delta to be epsilon divided by 2. I said if you choose epsilon to be 1 over infinity, I'm going to choose it to be 1 over twice infinity. Okay? We talked about that. And I'm going to make another statement, and you're going to wonder why I'm making this statement right now, but trust me, this is going to be really helpful for us to move forward. Okay? If I have this absolute value of x minus 2 is less than delta, I also know that 3 times the absolute value of x minus 2 should be less than 3 delta. So we've said x minus 2 absolute value is less than delta. Would you agree that I can multiply both sides of that by 3? You see why I chose 3? You don't know why I'm using this yet, but I will show you in just a second, okay? Second step of the proof. Just 2. We're going to show this to be true. Remember, the precise definitional limit starts out as let there be a function defined on an open interval, but maybe not at point A. Then the limit as x approaches a of the function is equal to L if for every epsilon greater than 0, there is a delta greater than 0. That satisfies this. So we're showing that this will be satisfied. Watch how we make this happen. It's very, very important. I'm going to make sure that this makes 100% sense to you. I'm going to show that piece when we have chosen delta to be epsilon over 3. So we're going to do a lot of rewriting, but it's just a much more formalized way of writing it. What is f of x? 3x plus 7 minus 13. Does everybody see I've written this so far? I eventually want to get to an inequality symbol. Before I get to this inequality sign, I'm actually going to use this right here. I'm going to use an equal sign. That is equal to what? To 3x minus 6. That happens to be equal to 3 times absolute value of x minus 2. Would you all agree? So far, I've written this piece. And these are all equal to that piece. Would you agree? Now I'm going to try to insert this less than symbol. Do you see this anywhere else up on the board? Where? Right there. See how it has a less than sign? So we know that this is less than what? 3 delta. So watch kind of the logic that you've shown. You said this thing right here, which is, so I'll use the red marker. This red part is actually all of this. Then I've used the blue part right here. What is the last part I need in order to make this statement? What's missing? Epsilon. I'm going to get the epsilon right now. What did we choose delta to be? Epsilon over 3. So see, I took delta, and in its place, I put epsilon over 3. What is 3 times epsilon over 3? Epsilon. Done. So we're going to do one more together, and then you have time to work through your assignment. But these are the 3 pieces. See that this all is the red? We're finally able to put the less than sign right here, and then this is all what becomes epsilon. It's just about choosing the right epsilon. Flip it over. You try to walk me through. What is the first step of our proof? Choose an appropriate delta. In order to choose an appropriate delta, I'm going to set up the absolute value of f of x minus L is less than epsilon when x minus a, absolute value is less than delta. So absolute value of what? 3 minus 2x minus -5, so plus 5, less than epsilon. Whenever the absolute value of x minus 4 is less than delta. Now what? Eight minus 2x less than epsilon. What's our goal? We want to make the left look like the, how would that happen? What do we have to do? Take out a -2. When you factor a -2 out of an absolute value, what does it become? +2. Yep. So if you think about it, I'll write this once. We'll factor out that -2 times, this becomes an x minus 4. This -2, I factored out. Would you agree that this expression here has to be positive? So you can always take a multiplier out and just make it positive. Doesn't matter whether this is +2 or -2, it's going to result the same. Everybody agree there? You're going to multiply it by 2. So that's 2 times the absolute value of x minus 4 is less than epsilon. Now what? Divide by 2. So the absolute value of x minus 4 is less than epsilon over 2. What does that mean? What? Great. Delta is going to be chosen to be epsilon over 2. I'm going to make another statement that's going to help me in my proof. Does anybody know what that statement is? 2 times the absolute value of x minus 4 is less than 2 delta. I just simply take this guy and multiply it through by 2. That's not required. I've just started showing that in the past 5 years so people can then understand why we make the last statement. So a lot of this is the proof, but the final statement comes with number 2. Number 2 says, after my smartboard stops being stupid, come on, buddy. Just get going. While it's blinking, I was required to post an e-learning assignment by today. So you have one posted. Do you think you find it on Schoology or on my website? Website, it's 12 practice ACT problems. That's it. I don't think we're going to have an e-learning day anytime soon, but I was supposed to have it ready for today, so I have it ready. Now, number 2, show absolute value of f of x minus L is less than epsilon whenever absolute value of x minus a is less than delta. We're going to show that that is true because, again, the precise definition of a limit says the limit exists if for every epsilon greater than 0, there's a delta greater than 0 that satisfies this piece. We have chosen a delta. What's our delta? Epsilon over 2. We're going to show that that delta over 2, or that epsilon over 2, satisfies this. So I write what? 3 minus 2x plus 5. Again, I want to make this statement here. I'm not ready to put in an inequality sign yet. What has to come next? Equals 8 minus 2x equals 2 times the absolute value of x minus 4. Oh, now I can put the less than sign. Why? Because it's right up at, yeah, you see it right here, this blue spot right here. So less than Well, what is it less than? Yeah, I'd like to say it's less than epsilon, but I can only say it's less than 2 delta right now because that's what this thing says. Equals 2 times epsilon over 2, which is epsilon done, QED, whatever you want to end your proof. That's the proof. So on Monday, we're going to start with you reciting the entire definition of the limit, and you got to be able to end it with this guy. You're going to use this today in your assignment. You have some proofs to do on the back side. I think that these are very doable proofs. I know that you guys got a distaste for proofs. Some of you like proofs in geometry, some of you didn't, but without a doubt, this is a more formalized analytical version of calculus. We say that you would see a lot of proofs done like this. It's good times. You guys are ready to go. Good work.